Hi guys, so we're going to be solving this question from the Woods and Raphael's textbook. So basically, a light source is reflecting on a flat area with a center x naught y naught, and this light source has a maximum intensity of 255. They're asking you the question that what's the value of k that will cause visible false contouring of the light source reflecting on the center on the flat area. Sorry. Now the question is what is visible false contouring? Let me show. This image is from ResearchGate. You can see the image on the left hand side is continuous. It's gray to light gray to white. You can't really see the discrete changes. But the image on the right hand side, you can see the discrete change, the abrupt change in colors. So that is false contouring. False contouring is when the eye can actually see the abrupt changes in color in an image. And that happens when we do something called quantization. So back to the question. The change in gray level between the adjacent quantized intensities will be change in G equals to K, that's big letter K, plus 1 over 2 raised power small k. And we know that visible false contouring, not we, but visible false contouring basically starts at 8 intensity bit values and above. I'm going to link a video down that will show you, that will demonstrate that. Now, we're just simply going to join the formula. K, the original K is 255, 255 plus 1, that's 250. So I'm just going to write value 256 over 3 power K. Well, that's what we're looking for. We're looking for value greater or equals to 8. So now we're going to make 2 power K subtract 256 over 8 greater than or equals to 2 power K. 256 divided by 8 is actually just 32. Equals to 2 power K. So we need to find the value of K that can fit this inequality. I believe 2 by 5 is equals to 32. So therefore, our answer can be that's not so different. So therefore, K is equals to 5. So at K bits of intensity resolution, we are going to start seeing visible false contouring in this light source that is on a flat area. So the second part of the question was to sketch the image in the above question for K equals to 4. Now for K equals to 4, 4 is the number of intensity bits. If the number of intensity bits is 4, then the number of gray levels in the image will be 16. That is in the torchlight. Remember, the torchlight is like a kind of circular source on a flat area. So we're going to actually draw 16 concentric rings to represent the number of gray levels, and it will range from 16, and the center will be of the highest brightness, 25. If you have shown a torchlight on the wall before, you notice that the brightest part is always at the center. So this is what it's going to look like. Now I was supposed to draw some extra things here, kind of line, and then trace these lines up. So it's just a lot of work, so I didn't do it. It's just some lines here. Maybe some lines at this point. Basically, it's just to show the discrete change in intensity value. So you can just do it yourself, but you get the whole point of the concentric rings. So thank you for listening. Hope you understood anything to understand. Don't hesitate to ask in the comment section. Thank you.